In this video, we're going to cover how to plan using an irregular surface compensator. So the first thing we need to do is set up this breast patient just like we would for any planning technique, either field and field or irregular surface compensators. So we'll add our plan. Go ahead and reuse course 3. Plan 2 is fine. We'll choose our breast PTVE volume. We can reuse, since there's already a point associated to that volume, we'll reuse it. And we'll go with a true beam 1. This patient is head first supine. For this plan, we'll go with 6x. Okay, we'll leave our isocenter as is in the middle of that breast volume. We'll use both this view to determine if our angle's correct, meaning limited or no divergence either through this breast here or through this tissue down here. But we can also use this view. So if I rotate this around and you look at that top right view, you can see where that back edge and that front edge are matching. So right here, we're too far over. You see this line here. We want to be right about there, right when that starts to disappear. Something in there, and you can see how that correlates with this view. So this line is fairly parallel with the back edges of this volume, so I think our angle's pretty good. We'll add a little bit of a margin on the top and bottom. We will add plenty of flash, 3 cm plus. Actually, since we're going to do an irregular surface compensator plan, let's do exactly 3 cm. Move this jaw right up against the edge. We'll draw our block. The reason I wanted to limit this to, I guess that's 2 cm. Let's do 3 cm. I don't want to add too much, because if I add too much for this type of plan, an irregular surface compensator plan, it'll actually cause the delivery to be longer, which will make sense here in a little bit. I think that field looks good. Let's oppose it. So rotate this one so that our MLCs match. This orange line back here is our MLCs. We want that to match. Looks good. It's a good idea to always review your flash for your lateral field. Sometimes you need to adjust that to make sure you have enough from both angles. Looks good to me. We'll put our prescription in and calculate. Let's review our weighting. Looks pretty good. I feel like it could just use a little bit more medially maybe, so hit F3. Add just a bit more medially. It's maybe too much. Something like that. So once you have your weighting set up, what we're going to do is right click on our field and choose New Irregular Surface Compensator. When you do that, this window pops up and we need to select a penetration depth. So let me cancel real quick, because what we need to do is measure how thick this breast is. It's about 23 cm. So a good rule of thumb when doing these new irregular surface compensators, remember this is 23 cm. Whoops. For this number, if this separation is a lot less than 24, you're gonna use 50%. If it's right at 24, you'll use 45%. If it's much greater than 24 cm separation, you'll use 40%. So this one was 23, so very close to 24. And remember, if it's a lot less than 24, you'll go up to 50. So you'll bounce that up. So 23 is in between, much less than 24 and 24. We'll maybe try 46%. We can go ahead and do that for both fields. Same number, 46%. Now before we calculate dose, what we need to do is, you can see our beam edge disappeared. So we need to recreate that. So I'm going to come here to isodose levels, turn everything in 3D off except for our 50% line. So your 50% line is always a good representation of your beam edge. So we'll use that to recreate our initial block. So to do that, we're going to right click on Fluence, come here to edit Fluence, and the idea here for planning with irregular surface compensator is, instead of us manually moving MLCs and creating those MLC shapes, we're actually going to edit the fluence pattern, and then Eclipse is going to calculate our MLC patterns for us. So to create this beam edge, we need to erase the fluence that is beyond this 50% line. Like that. The other thing we need to do is, it'll only calculate fluence right up to the body contour. Well, we want some flash, right? So we need to add flash. So there's two ways to add flash. I'll show you one way for field F1, I'll show you the other way for F2. So the first way is, we can use this tool here, the measure transmission factor, and we'll just measure a transmission factor right near the skin. So I don't want to go too much, like right in the penumbra region, because that might be too low to add proper amount of flash. So we'll go slightly in, about 1 centimeter from the actual edge. Measure that transmission factor, then we can use our paintbrush here. I'm going to use a brush size of 2, and we'll go ahead and paint flash into our field. And this is why I said I didn't want to open up my jaws too much, create too much flash, because the more flash we create, the longer the delivery will be. So something like that. Once I'm done with this field, I hit apply, and we just applied those changes to that fluence pattern. Now we don't have to close this window or change this window. We can just click right to F2. Something I forgot to mention, if you want to get rid of this kind of color wash here, you can do so down here. Drag that all the way to the left so we can see a little better. I'm going to again use my eraser. Erase all of this fluence behind or outside of our 50% line. like that. Now for this field, I'll show you another way to add proper flash. So I'm going to hit apply, or I could just hit OK. I'll right click on fluence, and we have this skin flash tool. So what the skin flash tool is going to do is it's going to just take this nearest fluence for every level and just extend it out wherever we paint. So I'm going to use this paintbrush. I'm going to change it again to 20 millimeters. So this one's in millimeters. And you can see you can't go into the body. It's only outside of the body that this works. Paint in however much flash I want. Something like that. Then when I let go, you can see it's just taking that fluence that's at that part of the body and just extending it out into space. So two different ways to do it. I prefer, so I'll apply here. I prefer using this method. This method tends to work better and gives us better MOSFET readings when we take MOSFETs for chest walls. Sometimes when I do it this way, I tend to get low readings because it leaves this thin area of very low dose, which I don't like, and I think that gives us low readings for MOSFETs and effectively underdoses our patient, but for this example we can just leave it. So once we do that, we've added our flash, we've added our block edge again, we can calculate. And here we go. So if we click this little caret here, we can actually still see our MLC pattern. And you can see it here too. What this yellow line here is representing the widest point of both MLC banks. So you can see the widest this bank gets matches our block edge, and then it goes all the way out here to our flash. But if we look at our MLCs and hit the play button, you can see the difference between what you've seen in the past, a field and field technique, and this irregular surface compensator technique. We basically are turning it into a, we are turning it into a sliding window technique, which is the same delivery as a IMRT field would be. So you can get some really nice dose distributions using this method. Okay, so we added we have both fields done, and you can see our dose distribution already looks pretty good. It's pretty symmetrical, pretty even. We just have a few little hotspots. So picking the proper percentage level right when you add that irregular surface compensator, so we went with 46%, which I think seemed to work out well for us. We have very good coverage right now, 100% covering 95, when really all we're looking for is 95 by 95. So the first thing I'm going to do is fix this normalization value. Click F3 and adjust our total weight back to 1. And now let's maybe reduce our coverage a little bit. So although we're covering very well by the 95% line, our 100 line does start to dip in quite a bit. Let's maybe let's go somewhere in there. So what I'm going to do is I have more than enough coverage, right? So even if I lose a little by cooling this plan down, I'm okay with that. So I'm going to shift from this normalization based on coverage down to just using our plan normalization value. Let's zoom in quick, kind of scroll through here. Let's turn our GTV on. So I think it looks pretty good. Our GTV at the top here, it starts to break up and it gets a little cold, but we can deal with that later. What I'm going to deal with first are these hotspots. So let's turn our 105 line on in segment in 3D. Probably still over 50. Yep. Let's turn that 50 off. Turn our PTV off. Okay, so let's start painting out this higher dose area. So I'm going to right click on fluence again, edit fluence. To make it a little easier to see, I'm going to get rid of this opacity right here. And the best way to do this, at least while you're learning and to start out, is if you measure this, or no, we'll do it this way. If you use this tool right here, so decrease transmission factors by defined value, and I suggest starting with 0.02. I'm going to change my brush size to 2 cm since we have a large area here. No, I'll use 1. Whoops. So what this is going to do is the transmission factor value at every point, I'm just going to decrease that value by 0.02. So I'm going to just start painting over this entire area. My left mouse button is held down right now. You have to hold it down the entire time. Making sure I just hit the whole entire area right there. I can see this area is in front, so I'll paint that. This area I think is in back, so I'll get that with my other beam. Let's get this area and this area. So what would happen if I let go of that left mouse click and then clicked again somewhere is I'll decrease it by another 0.02. So you only want to click, hold it down, and paint over an area once. Otherwise you'll decrease again by another 0.02 and probably make your plan cold. So just paint over the areas that we wanted. I'm going to hit apply, recalculate. Here it's telling us that it's just going to be a delivery method of a sliding window. You can see how that reduced very well, so we'll go to the other side. You can see by using that flash tool, it just creates all these weird cold spots. That's why I prefer this method. This method is just a lot cleaner. Okay, so I'm going to reduce this side again by a factor of 0.02. So I'll paint over this 105 volume. We're going to just keep doing this back and forth, very similar to if we were just creating field in fields. tiny dot of 105 right here, so I'll just click there to get rid of that. So usually when I'm doing 3D plans or field and field plans, I'd want to look at my dose distribution every so often. But for these, I tend to just focus on getting rid of that dose value that I want to get rid of first, and then we'll review our dose distribution, and I'll kind of explain that a little more when we get there. Try to get rid of all these little specks. Okay, so we've completely gotten rid of our 105% volume. So now we can come in here, scroll through our plan. Looks really pretty good. But now we have to look at our GTV. So we were already cold before we started, so we know we're at least still cold in that same area, but we've made it worse by getting rid of these hotspots. So now I'm going to zoom in. I'm going to right click over here. You can right click on any contour or on our structure set to add a new structure. I'm going to call it cold. And the type doesn't matter, you can pick anything. I usually pick avoidance because it's on the top of the list. And in external beam planning, you have this contouring, the freehand tool right here. So I'm going to scroll through here, carefully look at our GTV, and find cold areas. So this one's right on the line, so I'll just contour that there. I'm over contouring just a little bit. Okay. So this is why I don't necessarily go back and forth between editing fluence and reviewing dose distribution, because I can at the very end just fix my dose distribution and really focus on just those areas where I want to fix the dose distribution. So our plan is very cool. It's very homogeneous. We don't have even any 105. That's very good. So now we can just add fluence back only in this area, and we likely will have some 105, but it'll only be localized right to this area, and it's only here because we need it to get that deep coverage. So it's really a good way to really come up with the best possible plan you can. So we'll go here to edit fluence, but this time, instead of decreasing our transmission factors by a defined value, we'll use the one to the left and increase the transmission factors. So this time, since we're really trying to fine-tune our plan, instead of 0.02, I'm going to go a little smaller, 0.015. So this is a contour, so that contour is not going to change. We can look, we're still cold. Okay, so we'll go to the other side and do the same thing. Okay, still just a little bit cold, but we definitely gained quite a bit of coverage. So what I'm going to do is right click on this cold, clear from all planes. Let's redraw it quickly. Okay. The other thing I want you to notice is you can see how we don't have any 105 over here. It's only over here. So even though we just edited that fluence on that lateral beam, or F2, we're going to do it on that side again. Let's turn off our GTV so we can see that cold structure better. Change my brush size to 0.5 cm. Still just a little cold, so we'll do it again. Getting closer. Still no 105 on this lateral side, so we're going to keep editing our fluence on that side. We will do 0.02 since it's moving a little bit slower. Very, very close, just on that very deep edge of that GTV. So we'll just cover kind of this whole deeper edge. Increase that fluence. We're very, very, very close. Look at that, Mendoza 99.2. It might only be, oh, maybe a little right there. Just a couple slices. It's hard to see with that dose in there, so we can just turn dose off so we can see that tiny speck that we added there. Sometimes the draw tool goes away, so you have to cancel. Come back here to edit fluence. Draw just one strip there. One little strip there. .6. Do it again. 99. Oh, nope, min dose 100. So we finally got there. Perfectly there. But our hotspot creeped up. So what I'm going to do is, I know these two areas are our coldest spots of those GTVs, so we'll leave that on. We'll turn our dose back on. This 105 we just have to leave there. I know now that I need that to get that coverage on that GTV. So we'll turn that off, but we'll turn this 107 on. You can see right there. Let's check from this angle. Let's scroll through here. You can see it's on both sides. So it doesn't really matter which side we pick, but now we're going to decrease. So I'm going to try to avoid decreasing over that cold contour. Same thing down below. There we go, looking better. Go to this other side. Almost gone. Our GTV dose dropped a little bit. So we can normalize down. Let's go a little bit farther. $99.7. $100. So what's happening is we're really struggling. It just might not be possible to cover this deep with this separation with 6x. So when this happens, when you're kind of going in circles between raising, lowering your fluence and getting this min dose, and when you are only using 6x, we can just copy one of these fields and use a higher energy. So I'm going to copy this lateral field, F2, because our GTV is more on this lateral side. So we'll just copy that, change it to 10x, apply to only field F3. Put that at 0 for now. You can see our weighting just just went really high, so it's because I added a field, so now this isn't based on 1. And since we're not normalized based on coverage, the dose just went way up. So let's change it back to 1. Now our plane goes back to normal. Let's calculate that new 10x beam. To add a little weight first. So I only want to take weight away from F2, that lateral field. So let's lock F1. Start with 10%. Now we can calculate. So by changing some of this weight to 10x, our distribution's off. So we'll lock this 10x beam, rebalance that weight. Add a little more 10. Rebalance that out. A little too much. Very close. 99.8, 107, right up there. Probably just barely cold somewhere in there. So we're trying to cover deep, so we'll use our high energy beam. Just increase this fluence a little bit right back here. .9, so close. A lot of fine tuning, just trying to get rid of this hotspot now. We're so close. Okay, min dose above 100, max dose right at 107. We are done. So now we'll evaluate our DVH. We can of course do it manually. Since we have clear check, we'll use clear check. We'll use our hypofractionated breast constraints. You can see here, everything passes. We have very good coverage up here. Very low amount of 105, so that's the benefit of using this technique. You can get some very nice dose distributions. But look, now our hotspot max dose went up. If we were doing a field and field case, that would mean we'd have to likely redo all of our field and fields, and that can take quite a lot of time. But with these cases, and we could have checked this in the beginning, but it's actually just as easy to do it after the fact with irregular surface compensators, because we're going to just edit the fluence. So edit that fluence, use our eraser, simply remove the heart from the field. Do it on that side, do it on this side. Oops. I think I forgot to hit apply. So you gotta hit apply. So for F2, yep, forgot to hit apply. And now all green, well below our constraint. So they're not always this time intensive, not always as difficult, but definitely a way to get a very clean, very nice dose distribution. You can see we only have this 105 and this higher dose right in the area that we need it to get that deep coverage that we wanted. Everywhere else we were able to completely get rid of it, have a very nice homogeneous plan. We're able to make quick edits to the overall original block shape at the very end. I highly recommend using this technique and getting familiar with it. That's the end of this video.